Okay, welcome in, folks. This is our Design 300 lecture. It's week 7. Next week we'll do sort of a midterm. It's not like an exam. You're just going to sort of pull everything together that you've done so far. So that's kind of cool. So Design 300 lecture. It's Tuesday the 5th. The recording is on. We're on a Google Meet, and it is week 7. So let's take a few moments to go through what we're working on. We're working on flooring systems again, but this time it's beams and joists instead of slab on grade. So it's interesting. We'll have been through almost half of the semester, and we've gotten through the floor on the building. So then we'll have walls, windows, and doors, and roofing left to do, and then we'll be on to some individualized projects. So, but we're doing flooring systems. We're concentrating on beams and joists. We're not going to need software this week. This week, you're just going to look some stuff up. You will not need to be into Revit this week. We'll put the recordings on here. We do have a YouTube playlist. It's got a little bit of stuff that I think is really helpful. These are called IJoists, which is basically an engineered joist. So instead of having one big solid thick piece of lumber, they make it out of this kind of shredded and glued together stuff, OSB type wood that's very strong in this up and down direction. And then you just cap it so that it has something to sit on. And that takes far less wood for the same amount of support. So those are used more and more and more. Of course, there's a lot of formaldehyde in the making of this web piece, and we talked last week about formaldehyde. So these are cool. They're very steady. They're always the same. They're really cool products. And so there's a little bit about them. And then how to calculate a joist is a little bit difficult sometimes because there's so many things involved. And sometimes you don't have all of the answers before you start your design. So you use, if you don't have all the information for a calculator, then you go to joist tables and you just follow a standard. And you'll have a chance to work with that. So those are on there, and of course we'll add more. So after that, there's a reading list. There's again your flooring, and look, buildings haven't changed a lot since 2017. I do update these a little bit, so they're not exactly the same each time, but this is basically, buildings are still buildings regardless of when we're working on them. Okay, so here we go. We're going to take a look at a joist system and what it is. And so you can go through and try to figure out what this thing is, what this thing is, what these are, sort of how it goes together, sort of how they're blocked, and then some tables. Now this one happens, you can actually go get information off of it. This one goes to information. These ones don't. Okay, but this one has a link to information. So we'll talk about flooring joist systems and what they are. We'll talk a little bit again about standards, not so much master format spec this time, but the actual standards. And we'll talk about different types of standards and who's running the standards. And then we'll talk about it. Instead of just making a detail, we're going to talk about a detail and what's happening with it. So those are all part of what we're going to go over. Get to the right one here. My appointment calendar. You do have a little bit of stuff in here, not too much. You've got links to these already, so there's not a lot of resources that you have to get to this week. So, what are you going to do? You're going to do one posting this week. And, there he is. There's the guy you have chosen wisely. Of course, the guy before that did not choose wisely, and horrible things happened to him. And so here's a joist hanger selection guide from Strong Tie. And you look at it and you go, "Oh, what does all that mean, and how do I do them?" The thing I want you to look at here is, what is DF allowable loads, SP allowable loads. These are standard loading, and so how much can you put on them if you have this kind of a hanger. And then there's even the types of fasteners that have to go in with it. Okay. And then here's a little thing that helps you understand what some of those terms mean. So look at those guides and review the span tables, and then explain, okay, well, what do I need to know in order to choose a joist hanger? Can't just go out and buy any old joist hanger. I've got to get the right one. And so what do you have to know? What do you have to know? Okay. So, and that's a big part of this, is sometimes you look at a spec or a standard or a selection guide and you go, what? And you have to go look stuff up and figure it out. So there we go. Okay. And then you're going to do your joist material calculation and, of course, your submittal. So your joist calculation is really choosing a lumber size based on this data right here. Now I'm going to demo this for you. You can come down here and you can read this chart and you can put in the right size. And then this is going to tell you how much wood you're going to need. Okay. And so sometimes there's many different choices available, and you can choose the one that takes the least amount of board feet. And what is board feet? It's sort of the volume of wood that you use, but you can't just use volume because it's inch times foot. Whoever came up with that? Some person hundreds of years ago that thought that taking volume and measuring it inch by foot was a smart idea. But we still use it because it's in all the standards and it's been used for hundreds of years. And you can just buy X number of board feet of wood and then get it milled how you want it. So, thickness times width, or width times thickness in inches times how long it is in feet, are board feet. So this is 4 times 4 times 10. This is 160 board feet. And so I've done that calculation for you down here. Okay, that's inches times feet. That's how many board feet. And then your total is how many times how many joists you're going to use. I'll go over that one with you. Okay, so it's not too heavy of a week. It's a little bit light. You've learned a lot, and we're sort of done with the bottom part, the bottom part of the building. And the reason we do it this way is often the slab or the building pad is sort of already figured out. Like you look at these, quote, customizable homes, KB, Stanley Davis, things like that. And they'll go through and they'll pour all the building pads. And then you get to pick from 3 or 4 or 5 things that go on top of that building pad, but it's the same building pad right on down the line. And it doesn't look like You're in Cracker Box, same houses. They all look different with all the things that you can do. So we've sort of gone to this point, and then we'll start talking about the upper part of it. So let's take a look and see what your submittal will look like. Here we go. You got the good old things. There's your standards discussion posting. Joist material calculation and watching your videos. So people are doing a pretty nice job with this. I'm seeing good work on the visualizations. Tell me what you learned about flooring joists based on this reading here. And I want to see something about joists and span and load and blocking and joist hangers and use of adhesives and nails or screws. Okay, so I'm starting to look for more in-depth review than just taking a bunch of these pictures and slapping them on there. Okay, this last time through, I started applying a little bit more heft into showing me evidence. I want more evidence now, real evidence that you've done it, and needs more than just this one link. I'll expect you to look up joist, you to look up span, you to look up load, you to look up blocking, and then put some stuff in here about it. So you might even talk about like rim joists or facing joists, or and how these should be made. Do they have holes in it and things like that? And how do you put them on here? And these are kind of cool. Here's a joist hanger. Here's some blocking. What are all those things for? How does it all work? So, that's a fairly hefty one right there. And then the same thing about looking at the standards, and we'll talk about them a little bit so you have some places to go. But I want, again, if you can do more than just talk about these three standards. We're talking about the different types of stakeholders, and you might go look at other more interesting or in-depth standards for flooring so that you're done more than just the minimum right here. This one is fairly straightforward. We have this cool image right here. And you won't use this image. We're going to talk about it. You're going to find your own image that has materials, assembly or how it goes together, and functional or rating specifications on it. And you can find them. You're going to have to do a little looking to find one that has all three, but they're there. And you don't get to use this one. This is our demonstration. So you're gonna have a chance to look one up, and then you'll do the three parts of it. Identify the three parts: materials, how they go together, and performance or test parameters. And then there's a calculation that I showed you. Okay, no Minecraft this week. We'll get onto that again, probably starting in week 9 again. Okay, so pretty straightforward. I think it adds up 2, 4, 6, 8, 10. 10 points again. And there we go. So that's what's due for the week. And there's your assessment. So let's talk. We talked about this one a little bit, and that's good. I think I've gone over that one enough. Today I want to talk about the flooring systems and joists. So let's take a look and see what we've got here. So last time our floor went on a slab, so it was well supported. Wherever you stepped, there was support underneath it. But if you are not straight on the ground, and there's reasons for not being straight on the ground, you might have a crawl space underneath so that you can get under there and work on, the utilities that are running underneath. You might want to condition this space depending on what your weather pattern is where you build. Conditioning that space, actually having air conditioning, heating and cooling down there can be really useful because air is a great insulator. Heat does not travel through air all that well. And so if you can separate your building from the ground, which is always somewhat cold, mostly our ground temperatures are colder than air temperatures. If you can separate it from that, then you don't have to worry about your heat going into the ground, and you don't have to worry about cold coming up out of the ground. Sometimes you want to use that, believe it or not. So, but there's lots of reasons for it. Water is another good reason. You can imagine if you're up off the ground, you're not going to have water problems from the soil. Pests are another one. You're really reducing the amount of area that is directly attackable by pests. So that's one of the reasons why you would do something like this. And of course, just material costs. Pouring concrete is expensive and it's using a lot of materials. Okay, and as we talked, it's a little bit up in the air whether concrete is really a sustainable material. You can't grow more concrete. You can't create more concrete without digging stuff up. And we have been digging so much stuff up that it is starting to be a concern. Okay, fortunately, you can recycle concrete. Those are some of the reasons you might want to have a raised floor. And so, of course, you can't just have plywood sitting out in the middle of space. You have to have it something to sit on. So you will put joists across. And then there's all sorts of information. Are you going to use timber like this? That's timber. We're going to talk more about that. Or dimensioned lumber. Okay, but it's lumber, it's trees that have been cut. Or engineered composites, which can be laminated timber or can just be this nice cut up stuff and put into that direction. Okay, and then the span. The span is there's two ways to think about it. It's the distance between supports. Okay, so the span would be from this end of the joist to the other end of the joist. From this end to the joist to this end of the joist. That's the span. How far across is it until the next support? And you can imagine the farther apart they are, the less load you can put in the middle because this will bend. Wood bends, just like concrete is even more. Okay? And at some point, it can break. So if this gets too far apart, it can bend. And there are standards about how much bending you can allow when you walk on a floor or place a refrigerator on the floor or put a sofa on the floor. So there's only so much that these are allowed to bend before they go out of standard. And so these little tables over here are set to tell you if you have a certain type of wood at a certain size, 2x8, 2x10 or whatever, and a certain standard load, depending on how the building is being used, then you can put your span as much as some maximum number, as much as 15 feet, as much as 20 feet. as much as 12 feet. And that way the designer knows that if the span that they've designed is less than or equal to the table, then your design is acceptable. You don't have to do a whole bunch of calculations. You just look it up in a table. So that's why span is important. Now you need to know about loads because the way a building is loaded, where the forces are, is kind of important, especially to the design. If you overload an area, it will fail. If you design way too strong of a building, you're using too much material and it will be expensive and it will be bad for the environment. So you want to know about the load, which are the forces or weights that are on the floor. And there's two types of loads on a floor. There's a live load and a dead load. A dead load is pretty much the weight of the floor itself. It's never going to change. It doesn't move. It doesn't change. There's nothing live about it. It's just the weight of the floor, which is pretty substantial. You got all these joists. You got all these pieces to it. Sometimes you might have concrete on the top. You've got all sorts of layers. So the weight of the floor becomes a dead load. Then there's a live load, which is the stuff that can change or move around. A person walking around is a live load. A sofa, a refrigerator, a TV, a bed, a dresser. Those are all live loads because when you're designing the floor, you don't know where those are going to be put. Okay. Now, there are some standards that say if you design with this live load, you're pretty much going to be okay. Unless, for example, put in a water bed. Water beds are extremely heavy. Or you put in a 1-ton fire safe in one spot. Or if you know that there's a big piece of equipment that's going to vibrate, like an air conditioner or something. So in general, your live loads are sort of estimated on what's reasonable and normal. And you can look those up in these tables. Okay. And then the blocking, you can see blocking here. You can imagine when these get stood upright and you just, put a couple of nails into it, they can get kind of wobbly if somebody, if it wants to move sideways, which can be just normal use or earthquakes or just shifting of the building. All sorts of things can make them kind of want to move sideways. So sometimes you put blocking in there to keep these things upright. And sometimes the blocking is to block things. Okay, it's to block pests from moving around. Sometimes it's so that you can attach things. Piping can run through it and it can kind of support it. Sometimes it's to keep airflows down. It all just depends on what you're doing. But blocking is often used, and they'll just stagger them so you can just put a couple of nails in here, turn around, nails. Nails in here, turn around, nails. Okay, so that's what blocking is. So those are important things to know about a floor and how it's built. And those are all independent of what's going on. Now, once you've got a span, you got to figure out what's going to support it. Like these ones are being supported on what's called the sill plate or the bottom plate. So there's a piece of wood on top of the concrete, and there's probably some sealant under it and vapor barrier and flashing and all sorts of stuff. But the ends of these pieces, of these joists, are just going to sit right on that piece of wood. And then they're going to get nailed into place. And this one's got what's called a rim joist. And that's going to go along the outside. That helps stabilize things and make it strong too. So those don't just fall over. Okay, but this one's being supported by the foundation, so that's cool. But you don't always have a joist that's hung that or supported that way. Sometimes the foundation is only at the edge, and you need something on the other side, and you might have a beam, a cross beam running down the whole thing. That's a big thick one, and that beam might be supported by columns, right, pier and post. And so sometimes it's just the easiest way to build it is you just put a big 2x8 along there, and you just use joist hangers to hang all of your joists. Okay, and that's a very strong, very standardized way. In other words, you know how much load that joist hanger will hold. They've designed them, they've engineered them, they've tested them. If you use a certain size nail or screw on the pattern that they give you, and you put them in the right order, and you drop this in there and tap it in and put it in, this will hold a certain load. And they can tell you reliably that that joint will hold a certain load. And that's really, really cool. That's great from the design point of view when you can absolutely know what load that can hold. That's just wonderful, wonderful news. So you should know about joist hangers. Sometimes there's a lot of adhesive involved. The adhesive is often on the flooring side, where along the top of the joist, you'll run adhesive as well as glue, as well as nail it. That's fairly commonly done, that you get adhesive in here with these. And of course, nailing and nail guns, bang, 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 bang. Nail guns are very fast. They're not as maintenance free. They don't last as long as a nail because wood shrinks and it expands and shrinks and it expands. And the weather has a lot to do with that. Age has a lot to do with that. When you just pop a nail in, it may be strong in one direction and not strong in another direction. And it also depends on what direction you're nailing into. So that's another thing to know about. When you put these joists in, you have to look at the wood and see which direction the grain is so that your wood, your nails don't split the grain under load. They are actually held by the grain under load. So you actually have to look at the grain on a joist to make sure that it's good. And it's not in this one, but there are nailing pattern tables that say what is the load if you're nailing with the grain and across the grain. So there's a lot to know about these things. You don't have to know everything. They're all in the tables. And you know, this is not a construction design class. It's a material resource class. What is there? So you should know that there are nails. You should know that there are adhesives. You should know that there are joist hangers. You should know that these things exist, and you should know where to maybe go find them and look up some information about it. So there we go. That's another good reason to use these engineered composites too, because you can also pick these end pieces to be. It's easier to find those with the cross grain, but it's not quite as important depending on how you're attaching them. If you're hanging them or supporting them from underneath. So there we go. There's a little bit about a joist floor system, a joist system. It's a bunch of pieces going across. They're horizontal and they're going to support the floor. and you put them at a certain spacing so that your floor doesn't sag in between them. And that depends on some of the loading too. And then you put your subfloor down just like you put your subfloor on the slab. So these joists essentially serve the same purpose as what we learned last week was the slab. Okay, so there's a little bit about a joist system. What is it? Let's talk about standards. So it's really important that you know who made up the standard and who supports the standard and who accepts the standard. I could do the ARC 5-star gold standard of design, and I made it up as American River College Design Technology Department. And I wrote it down, and I think it's awesome, and it's great, and it's complex, and it's complete, and nobody would use it because I made it up myself, and it has no standing, and nobody's seen it, nobody's tested it, and nobody knows who I am. So standards do get developed by different people in different groups, and those people and those groups are called stakeholders. Who has a stake in the design and in the standard? And there's a bunch of different types of commonly used standards that are well accepted. But again, you have to look at each one and see if that standard is appropriate to your needs. So here are some flooring standards as an example. CRI, Carpet and Rug Institute. I mean, who made that one up? Well, I looked at it. There's a ton of manufacturers and a ton of sales groups, and there's even some architects and interior designers that belong to the Carpet and Rug Institute. And so that's what's called an industry-based organization. When you get a large number of manufacturers, now if this was like, one floor company that was pushing their own product, you sort of go, really? No. But if you look at who belongs to the Carpet and Rug Institute, you'll find a lot of them. A lot of manufacturers that do, and they cover a wide range of products and a large area of the country. So you can go, okay, and it's really a standard for how to install and maintain a carpet. So you can see why manufacturers want to have something like this, because then they can go and you have to install it and maintain it per CRI 105. Okay, for residential carpet. And that's all they have to say. They don't have to say, and you have to make sure that the floor is bare and it's clean and there's no warp and there's no nails sticking up and the wood has a minimum number of knots, and then you have to put an adhesive down and a vapor barrier, and then you have to put a cushion down of this size. You just say, follow these standards, and you're done. And then it's up to the contractor to know the standard and look it up. So these are really nice, and we'll take a look at this one. And you can imagine, if it's your carpet and some, local yokel put it in that doesn't really know how. And I'll tell you, I have met some carpet layers, and I've got the utmost respect for carpet layers. They're awesome when they're good. I actually knew the guy that used to be the carpet layer for Nugget Hotel, the John Esquaga's Nugget, and he would travel all over the country whenever they had a project, and they always had a project. They were replacing their carpets every 2 or 3 years in some places. And oh my gosh, how fast they could put a carpet in. And there was it was amazing. It wasn't ugly like if I did a carpet. So this tells people how to put in a carpet, right? It's the carpet standard. Okay, and you can get it. Here's the download. Man, look at all these downloads you can do. Here's a PDF download. And let's just see. 47 pages on how to install carpet. So you don't want to be the expert in this. You want to trust an expert. And you can probably, and there's the trick, is who will you trust? And all these red things are things that you can take out or add or leave in there. Wow, this is pretty cool. About us, who we are, commercial stakeholders. And they've got even health benefits and environmental efforts. So they have a green label. Still trying to find everything about who they are. Doesn't really say their list of government news, testing, right? So they do stuff. Oh, there's the member directory. There it is. 93 members, right? And so you can go through here and see who might be, and you can see there's a lot of Georgia. Now we're into some Californias. So these are people that want to do work and want to do work well and want people to go, we want people who will for sure do a good job. Okay, but they're all over the place. And so you can go, okay, yeah, I got it. These are some people that have done some, look at Electrolux, they're huge. Engineered floors, these guys are big. Okay, but you'll see, man, there's a lot of them in Georgia, right? That's because tons of flooring products come out of Georgia. Tons of flooring projects come out of Georgia. You can look at this and you go, okay, it doesn't look like there's just one group that's kind of running the whole show. It's like there's lots of people. Oric, they're a big one. Prochem, they're a big one. Don't know who they are. Rubbermaid, they're a huge one, right? Rug Doctor, they're gigantic. Scotchgard, they're gigantic. Know some of these other ones, but so that's how you go about kind of checking things out to see what's going on. Right? And you can read this spec. Go, okay, got it, man. They really have good directions. So that's called an industry-based organization because there's industry members that are running the show. Now there's another one that's called the consensus group, and that has many stakeholders. It'll have more than just industry. It'll have users. It will have suppliers. It'll have designers. It'll have government groups. And so you've been into this group before. ICC. Okay, digital codes are part of the International Residential Code. And we've been looking at this one, right? So you can go over here to their home and find out about them too. Somewhere. They're not as easy to find stuff in. Um, okay, but look, they've got a lot of codes available. Search by category, standards, ICodes. And look, these are all real common standards that you might find. And what they're saying is all of these standards are reviewed and included in theirs. Codes by state. So this group is basically taking these codes and rewriting them so that they're available for free. That's pretty cool. Okay. And really, I mean, this is not that expensive, and you can get them for free. Okay, and here's who all the players are. So they're a pretty big group, and you could get a hold of them. So that's a much larger and more powerful set of standards, but you probably won't find specifications quite on the how-to level as this one, this group. And the last one are special interest groups, and there's nothing wrong with special interest groups. Special interest groups just have a special interest, and they might be the most knowledgeable people about that special interest. But you do have to watch out because they're often so focused that they can't see the forest through the trees. And they get so focused that they only use one criteria in their design and analysis of the analysis of their designs, and that can lead you astray. So here's an example. EWG's Healthy Living. So let's take a look. EWG's Healthy Living. I don't know who they are. So these are their principles that they use. Avoid laminate. Install without glue. NAF certified. Low VOC. And these are all great things. These are all great things. They are certainly healthier. Just about every choice that you make that is this, that is not this, doesn't last as long and doesn't wear as well and might look crummy. And, like natural linoleum tile has its own problems, that it peels up. It's not as waterproof. It doesn't stick together as well. So these are definitely healthier floorings. And in general, when I teach design, I suggest that people try to use these as much as possible, especially when you read the MSDS of some of these other ones. But avoid laminate, right? We all know why that is. Okay, vinyl and synthetic. The stuff that's in there is just not good. Do's and don'ts. Avoid VOCs. Okay, made with formaldehyde. Laminates made with formaldehyde. Vinyl flooring made with formaldehyde. Synthetic carpeting made with formaldehyde. So you can see, this is pretty cool. These are great design principles. They all cost more and function usually less. But that's the whole idea behind good, solid design standards. So our California design standards now include, Cal Green. They now include requirements to design in this way, which have been around for years and years and years. But we put policies in place to enforce this now. Now there's enforcement. So you can follow these and not have to worry that somebody else will be cheaper because they avoided these. Okay, but this is very definitely a special interest set of standards. Look at all these things fused together using glues and resins from formaldehyde. Phenyl formaldehyde is pretty bad. It says the urea formaldehyde is the worst. Sustainability, recommended floorings, blah, blah, blah. So we don't really get to know. So look, they've got all these ones. This is, there's a pretty cool site in reality. If you want to look at stuff, they've got some really cool stuff, right? And it's a great resource, but you're going to have to check it and make sure that you're doing okay. Okay, that you're taking everything into account, not just formaldehyde. So those are 3 types of standards. And so in your thing here, you should make sure that I understand that you know that there are 3 types of standards and why one might be in one way and one might be another. And you can just look up those 3 types of standards and see what else you might learn about it. Okay, so our last thing for today is to talk about detailed drawings. And I think this is pretty self-explanatory. Details often tell you the materials of construction. Notice there aren't any dimensions on here because it's not about the specific design dimension. It's a detailed drawing to show materials of construction: lightweight concrete, wood structural subfloor, corded truss, batting insulation, gypsum board. Those all tell you about what material you're using and then how they go together. See the structural drawing. 24-inch on center, 2 layers. So sometimes they tell you how they go together. And sometimes they tell you how it has to perform or what standard it has to meet. 1 hour rated per STC 55. Okay, and that's probably a fire rating. So it has to perform under a fire test. So it's got materials, it's got how it goes together, and it's got what has it got to be able to do, a performance or test parameter. Okay, so your goal will be to find something like this and identify it sort of in this same way. Okay, so there we go. That is what I've got to cover for today. That's a chunk, but we're getting to the point where I think you guys can handle that much information. And on Thursday, we'll go over the joist material calculation. Okay, so there we go. That's our recording for today. And I'll get this posted and see you on Thursday.